LeetCode problem number 104, maximum depth of binary tree. Given the root of a binary tree, return its maximum depth. A tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. Okay, so for our first example, we have a binary tree. The root node is 3. It has two children, 9 and 20. 9 doesn't have any children. 20 has two children, 15 and 7. So our longest path would be 3, 20, and 7. Or 3, 20, 15. But I'm assuming it's 3, 27. And our output is 3. So we just want to go to the furthest down that we can go. And then we have example 2, where we just have 1, null, and 2. So that means it's, let me see if I can do it. So this would be the root, and then null means there's no left, and then on the right would be 2. So then our visualization will be 1 and 2, so the depth will be 2. Okay, let me also do the first one out, since it's easier to see when it's like out, spelled out. Then we have 20, and then we have null. So null just means there's no children for here. So we have null, null. Okay, let's move this a bit. Then we move this one a bit, and then we move this one a bit. So 9 has 2 nulls, we see here. So this is the first, and then there's 2 children. So here, since there's 2 children, this is the max. Then we go to the next set. So these are the children of 9 and 20. So children for 9 is null, null, so 2 nulls. It doesn't have any children. And then we can come to 20. It has 15 and 7. Okay, so we have, this is it, 1, 3, 20, and 7, which would be the longest. Okay, so let's read the question again. A forgotten given. The root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. Okay. So we understand what is happening. Now we need to code. The number of nodes in a tree is in the range of 0 to 10 to the 4th power. Negative 100 is less than or equal to a node value, which is less than or equal to 100. Okay, so we have values, a val, int left and right tree nodes. Okay. Whew. These ones are going to be a little bit more tough than what we know. So first thing we need to do is find the maximum depth of a binary tree. So we can use the left and right to find the max depth. And then return our max. Right. Okay. How are we going to find our max? Let's read some description or discussions. See if they are of any help. The newest to oldest. Hopefully no one posts any answers. Took 1 month to solve it. That is not a good. If you're a beginner, find DFS a bit more. Return the number of levels in the trees and level reverse. Recursion is a god. So we can use recursion by calling the max def inside, and y after 20 is null for left and right node. So we have 3 null. So 9 doesn't have y after 20 is null for left and right node. The nulls would be for 9. 20 would get 15 and 17. Okay. So we have one hint, recursion or BFS. Okay. But it said this one is under DFS. That's why I'm trying to stick with the BFS. Okay, this is so easy when you know about recursion. Binary tree and recursion. Okay. We can do recursion. How are we gonna do recursion? We can use our max depth function and probably use these up here. So we can do left side, right side, and then pick the one that's max. Yeah, we can use max and then compare the two, which is the bigger, left side or right side. That, let's see, if left is 2, right is 2. Okay, maybe we need another example. So let's copy this one. Let's see what happens. So I have 3, and then let's do a 4th level. So null will have 2 nulls. This will have 2 nulls. And then maybe we give this one like a 1. And this will be 1, 2, 3, 4. Okay, let's do 1, 2, and then let's do 6, 7. So our left side would be 2, our right side would be 4. So the right side, we need to return the number on the right side. Okay, let's start to code. Let's do left side. We're gonna use recursion, so we'll use max depth. Yeah, you're right. Recurse down to left side, down the right side. All right, great. I'm on the right track. Okay, so our max depth function needs a tree node, so we can use left root. We're passing in a root, so we can do a root, maybe left. That would be this. And then since we're passing in a root, whatever we're passing in, we want the left. Traversal. And then let's do the same for right. So max depth. And then do root right. And then what? Return max. This might be max left side and then right side. Something like this. we need to return an int, so that this should work. This should work. So we're getting the max for left, we're getting the max for right, and then we're trying to return whichever one is bigger, because we want the biggest number. Then one of our examples, we tried it. So this example, this is a comment. So this example, since we had null on like first, second, third level, that means the fourth level for what it shouldn't have numbers for the left side after 9. So that would be 1, 2. And since we went down to the fourth level here, this should return 4. And then in our return statement, 4 would be bigger than 2. It should return 4. Let's run it. Value optional. Okay, let's make these lets. I don't think we're not doing anything to them. The value, oh, it's optional. Okay, that didn't work. Let's do something up here. Let's do a guard statement. Oh, can't see. Oh, my screen isn't changing. That is not good. Give me 1 second. What screen am I even broadcasting? Let's just show it now. No, it's not. Or let me just show my laptop screen. This is gonna take too long. Okay. And then I'll just watch on my phone. Can you see now? Yeah, it's visible now. Okay. So left side, right side. What was I dealing with? The optional. Okay, let's just do a guardlet. Do a guardlet. So let guardlet root equal root else return else. We are going to return 0. No, that's not how you do it. Should we do else return 0? So if there's no root, there's no tree. So we are returning 0. And that should solve this error. Value of optional type tree must be unwrapped to refer to member left of wrapped base type, blah, blah, blah. Okay, so that should work. Let's run it again. Wrong answer. Output. Expected 3. Expected 3. Okay. Let us rethink. So we have our guard statement. So this should give us max root of left, max root of right, return or Return max left, max right. What am I missing? So you're not calculating the depth. It says return its maximum depth. So let me see if it's just a IDE thing. Nope. Okay. What am I doing wrong? Root left. Then max depth. Turn in. Okay. So we are getting the left side and we're getting the right side. And then returning. Okay, let's see if this is even returning the right. Okay. What is being said? Oh, I wasn't accounting for the current node. Okay, this worked. So depth plus 1 for the current node. I'm not seeing my comments. Okay, so we're getting the left side, we're getting the right side, we're getting the depth, and then we did plus 1 to account for the current node. There are some functions up here. So let's submit and see. Okay, please give me 1 second. I'm getting a call.